Hello, and thank you for joining our presentation. My name is Carly Thalman, here with my team to present the SR-HExo for active stroke rehabilitation. Our design combines principles of soft robotics and mechatronic systems to provide active hip assistance to individuals suffering from neurological disorders or effects of post-stroke impairments. Traditional methods of gait therapies for those suffering hemiparesis after a stroke rely on expensive, rigid, and bulky exoskeletons for support and gait assistance. We're aiming to provide a comfortable and adaptive solution to address these three main goals. Maximize comfort through a lightweight fabric-based solution, extend rehabilitative capabilities through powerful actuation, and offer a low-cost, easy-to-manufacture solution. Our team presents the SR-HExo, which meets these criteria using soft, compliant materials controlled through pneumatic actuation and custom controls. The SR-HExo consists of two sets of soft actuators to assist the hip. These actuators are lightweight, and the system is modular to fit the trunk size and shape of various users. These actuators are patented flat fabric pneumatic artificial muscles, or SR-PAMs, made from heat-sealable TPU-coated nylon that can lift considerable weights despite their inherent compliance and low profile. The front pair assist hip flexion, while the back pair of actuators assist in hip extension. The SR-PAM actuators are made from TPU-coated nylon, which is heat-sealable. The SR-PAM actuators have a high force-to-weight ratio and can generate strong tensile forces when pressurized in a short window of time. This makes them an attractive solution for wearable applications as they are extremely compliant and low profile when inactive or unpressurized. In this application, the SR-PAMs are oriented in an X shape to hug the musculature of the leg and achieve a low profile suit to allow for full range of motion in both flexion and extension of the hip without significant loss of effective payload. As shown in the graph on the right, the X-ff-PAM orientation is just as effective as the parallel version for both dynamic loading and recovery response to 200 kPa of instantaneously applied pressure from the valves. The benefit of orienting the actuators in this X orientation is to prevent restriction to the user's range of motion after donning the exosuit and allowing more complete mobility. I'll now hand the floor over to my teammate Lily.
Thank you, Carly. The unique innovations of this design are its weight, torque capacity, and cost. The complete worn exosuit assembly weighs just 1.8 kilograms, which is lighter than the lightest exosuit on the market at 2.1 kilograms. The torque capacity is 28.5 Newton meters, where the lightest competitor delivers only 12 Newton meters of torque. Manufacturing the exosuit costs less than $450, where the lightest commercial competitor costs just over 80 grand. Locomotion is assisted with the SR-HExo by timing actuation with critical gait events. As you can see in the video, posterior and anterior actuators activate at 10 to 45 and 50 to 90% of the gait cycle respectively, aligning with natural maximum hip torque in flexion and extension. A custom integrated control box houses all electro-pneumatic hardware to implement the needed activation of each actuator set during designated times throughout the gait cycle. Preliminary test results for muscular activity and range of motion are promising. The SR-HExo significantly reduces muscle activity of both hip flexors and extensors, as shown in the graph on the right. Despite this significant reduction in muscle activity, on the left side of the screen we can see that range of motion is not dramatically impacted over the course of the gait cycle, with an overall change of less than 5% from nominal values. There is great market potential for our exosuit. There are as many as 8 million stroke victims suffering from hemiparesis each year in the United States alone. Our design provides a pneumatic soft robotic hip exosuit that is effective in reducing muscle activity with high torque output without a large suit profile and is the lightest of all commercially available products. At a manufacturing cost of approximately $450, our design is considerably more affordable than on-the-market exoskeletons. Additionally, our lab already has clinical partners in place, ready to assist in patient response characterization. Experiments are already underway to quantitatively characterize human response to our exosuit. According to our 5-year target for product development, we are on schedule with product refinement and optimization. We are also investigating expanding product portability to increase the total available market. We plan to have a finalized product by early 2023 that is ready to push to market mid-2024. Here are our references. Thank you so much for your attention. Please feel free to ask questions or follow us at the following links. Thank you.